Hello everyone. We have discussed in last classes the different aspects of neurophysiological comfort related parameters. We have discussed that there are different types of receptors present in the human skin, and these receptors get sensations from environment and clothing, and ultimately it sends signal to our brain. In the first segment we have discussed the mechanical receptors. So, different types of mechanical receptors we have discussed. We have discussed the tactile receptors, receptors for pain sensation. Then we have discussed various sensations related to clothing, like prickle sensation, itching sensation, skin rashes. Okay. This all we have discussed related to mechanical reception. Now we will start the next type of reception, which is thermal reception. There are different types of thermal receptors we have discussed, we have mentioned earlier. Now we will discuss in detail. So, if you see, the receptors are of basically 4 different types of thermal receptors are there. One is cold receptors, that is that sense the cold sensing it has got. Then heat receptors, it sense anything warm, and within these 2 receptors, thermal receptors, there are 2 more receptors which deal with the pain, like pain due to cold, extreme cold, and pain due to extreme heat. So, this all receptors we will discuss here, and related activities when we wear clothing, and we should have clear understanding about this type of receptors, how do they work, to understand the thermal comfort behavior. So, these are the receptors we have discussed. Basically, thermal receptors, suppose pain receptors, this is a say hot spot is there, hot object, some flame. So, if it sense our skin, our pain receptor, if it sense that there is an hot object, so it immediately sends signal. The transmission of signal that we have discussed in last class. So, it sends signal to through the spinal cord and to our brain, and our brain reacts. Okay. It evaluates, okay, then it reacts, and ultimately it sends back the signal again to our muscle, and muscle contract, and our hands we can move out of the flame. So, this way it in the closed loop it works. So, if we see the thermal receptor, the nociceptor of hot pain receptor, it is receiving signal and it sends back the signal to the brain, and this way it works. Now, sensations related to thermal stimuli is that the skin has it acts as a barrier between our environment and the body. Okay. It is our internal organism, okay. And the idea of this barrier is to maintain the core temperature within a very short range, that is 36 degree Celsius to 38 degree Celsius. Okay. That our body tries to maintain this temperature by physiological activities. The skin is the most important organ of human body through which heat and moisture flows out from the body to the environment when it is required, and from the surrounding it receives if it is needed. Okay. So, that through skin the heat and moisture flows to keep the heat balance of our body. So, when our body gets warm, okay, it transmits heat from inside to outside through skin. Okay. So, to maintain the heat balance, the skin, in addition to this making heat balance, it also has got thermal sensor which actually regulates the human physiological activities. The skin, this thermal receptors take part in the thermoregulatory control, and this affect the person's thermal sensation, okay, and related to comfort. The complex vascular system and sweat gland actually in the skin helps in maintaining the conductance of skin in response to the thermoregulatory demand. What does it mean? So, it actually, the human skin actually when we feel warm, so to release the heat, it starts physiological activity started. So, by to release the excess heat, it releases the sweat. So, and our conductance of the skin also changes. So, the human skin contains basically 4 different types of sensors, that is thermoreceptors, and these are basically nothing but nerve endings. So, these nerve endings are, one is cold nerve ending, warmth, then hot pain and cold pain, and each of these receptors, they have their own range of activity, means within that particular range they are active, beyond that range they are not active, some other receptor, thermoreceptor will act. Now, let us see, and also their presence in the body is not uniform. In our human body it is not uniform. So, it has been observed that in some places, suppose on with a small object, okay, when it is touched with the skin, our skin, it may get, some places we may feel warm, or some places we do not feel, which what does it mean? That is the distribution within the skin of this thermoreceptors, cold receptors or warm receptors are different, and it is not present throughout the body uniformly. So, a small hot object, suppose if we touch at different parts of our body, in some part we may feel warm and some part we may not feel that. Okay. That means, the point where warm receptors are present, there it sends, it actually sends that signal. Okay. But the places where warm receptors are not there, that it does not sense. Similarly, in case of cold receptors. Okay. So, within small warm and cold stimulator. Okay. So, that touched with small warm and cold stimulator, suppose with the help of warm pin, if we touch. So, this is actually proved. So, that means, so its distribution at different places are different. Let us see with this picture. So, if we see that the distribution is that cold receptors, number of receptors, cold receptors are much more than the warm receptor. If we see, like, and maximum concentration of cold receptor is at chest, where typically it is around 10 receptors per square centimeter, and least at the say finger, where it is maybe less than around less than 2. So, this receptors per centimeter. So, that is a type of, so less than say 4 receptors, 3 receptors, around 3 receptors there. That what does it mean? That means at the chest the concentration of the receptors are very high, where that means it is a highly sensitive to our cold, and that is why we feel too cold, we feel cold sensation at the chest region very fast. Okay. And this outer part of the finger also it is very high, it is around 8. So, this type of data gives the clear idea about that where do we want to keep our body warm. Like one simple example we can see, suppose when we feel very cold, suppose we are not clothed, so we feel very cold. So, if we wrap one a piece of cloth around our chest, we suddenly start feeling warm. Similarly, if we wear gloves, so that outer side of the finger with a very high number of cold receptors gives the warmth. Okay, it is that it sends cold, and that is why it gives when we wear gloves, it gives the warmth. Okay. Similarly, if we see on the other hand that warmth receptor, number of warmth receptor is very less, very low. So, it is less than 2. If you see that most of the places it is less than 2 per square centimeter. Okay. So, this distribution if you see, so it says that if we touch at a particular place, there it may not be available, the sensors may not be available. So, it will not sense. Okay. And so, these are the places, 2 different zones we can see here, where the maximum and minimum receptors are present, concentration of receptors. So, now if we see the discharge frequency of these receptors, cold and warmth receptors, if you see, even cold pain and hot pain receptor at different temperature. So, this picture, this schematic diagram, it shows that the cold receptors, it starts sensing around say from 7 degrees Celsius. At 7 degrees Celsius it starts sensing, and maximum frequency of reception, that is discharge frequency, is maximum is around say 25 degrees Celsius, and with the further increase in temperature, its actually reception discharge frequency reduces. This means that the cold receptor, a particular cold receptors, it starts sensing whether it is a cold, okay, only cold, it starts sensing from say 7 degrees Celsius or 8 degrees Celsius, and it stops its sensation, its activity around say 45 degrees Celsius. So, that way, so this is the zone of activity. Similarly, normal warmth receptor, it starts its activity around say 35 degree, say 30 degrees Celsius, and maximum activity is around say 45 degrees Celsius. So, at 45 degrees Celsius its maximum discharge frequency, and as the temperature goes on increasing, its discharge frequency, its sensation, it drops, and it stops sensing any further increase in temperature beyond around say 50 degrees Celsius. So, its activity range is from say 30 to 55 degrees Celsius. So, 30 to 50 between say 30 to say 45 degrees Celsius, in this zone there is a overlap. So, both the warmth receptors and cold receptors, they are active. Okay. But maximum activity of warmth receptor is at 45 degrees Celsius, and for cold receptors it is around say 25 degrees Celsius. This we have discussed, and suppose Now, what happened beyond this? So, beyond this we do not feel either warmth or cold, like say if we start our if we the temperature start dropping beyond say 10 degree 15 degree Celsius. So, around say from 15 degree Celsius our cold pain receptors start its activity. So, and as we keep on reducing the temperature, okay, from 15 and below, so gradually its activity discharge frequency increases. So, what does it mean? So, at 15 degree Celsius it starts sensing, we start sensing a little bit pain, okay, like and then around say 7 degree Celsius, 7 degree Celsius we do not feel cold. So, say at 0 degree Celsius and cold receptors they stop its sensation. So, cold receptor does not work at below say 7 degree Celsius. So, it stops working and then the activity is for only for cold pain receptor. This means we can get daily example, daily we sense this type of sensation, like when the at the temperature we keep temperature keeps on reducing, we start feeling cold, okay. Gradually we start feeling say 40 degree Celsius, we 40 to say 35 we start feeling little bit cold, because this activity of the cold receptor increases, the discharge frequency increases and gradually this activity is maximum. But when it is at 5 degrees Celsius, when it stopped, it has been taken over by the cold pain receptors, and at 0 degree even sub 0 degree Celsius its activity on. So, that particular temperature, although it is a cold receptors, cold pain receptor, we do not feel normal cold, we feel cold pain. Cold, we know it is a cold, but it is a cold pain receptors. That means normal cold, the normal cold receptor is different and cold pain receptor. Suppose one example is that, suppose on ice block I am pressing against my skin, what will happen? Ice temperature is say 0 degree Celsius. In 0 degree Celsius we feel cold, but it is mixed with the pain. That means its normal cold receptors it stopped working, then cold pain receptor has started its work. Similarly, in warmth receptor it stopped working at 50 degree Celsius, and beyond that the hot pain receptors. Very common example, suppose boiling water we put our hand, we will not feel basically warm, we will feel warm with actually pain. That means our pain receptors will start its work. So, there are 4 different types of thermal receptors we have discussed, and now so all as we have explained here. So, all these nerve endings, the thermoreceptors sense the temperature of the skin and transmits the information like our mechanical receptors we have discussed to our brain, okay. And this cold and warmth receptors actually it is in the human skin are responsible for sensing normal environmental temperature. So, it is not harmful to our body. So, this is this normal cold and warm receptors, but the harmful temperature which is actually can damage our body, these are sensed by cold pain receptor and hot pain receptor, and after sensing they accordingly our body physiology work and our brain sends signal, and they accordingly our muscle and all this closed loop system start working. So, our in normally in clothing comfort we are concerned about the normal cold and normal warmth receptor, okay. We are not concerned about the cold pain and hot pain receptor, although the cold pain in extreme hot extreme temperature, the environmental temperature is it is beyond this normal temperature, but our clothing has to bring down this extreme hot or extreme cold to the normal cold and normal warmth within the our microclimate zone. If we cannot, then we will not feel comfortable. Okay. So, and this part we have discussed in detail. Now, it can be observed that the warmth receptor that we have discussed now, it starts sensing the temperature around 30 degrees Celsius and it ends at 50 degrees Celsius with the maximum impulse frequency is 45 degree at 45 degrees Celsius. Okay. And similarly, the cold receptors, if you see the and hot pain receptors, it starts its activity beyond 50 degrees Celsius. Okay. At that time the warmth receptor stops its sensation. Similarly, the cold receptor, if you see, the cold receptor starts its activity from 7 degrees Celsius to 40, typically around 42 degrees Celsius, and maximum activity as 25 degree Celsius. Now, the cold pain receptors, it starts its activity below 10 degrees Celsius, around 15 degree, below 10 degrees activity starts, and at that time the cold receptors are inactive. So, at lower temperature cold receptors are inactive. Now, if you see the location and number of sensors, so the distribution and of warmth and cold receptors, it is a concentration of this type of receptors, as we have discussed, are different at different zone of our body. We have mentioned that at the chest the number of cold receptors are more. Okay. So, and warm receptors are much less than the concentration of warm receptors are much less than the cold receptors. So, that is why that we have seen that, and also the location of cold receptors around say 0.15 to 0.17 millimeter from the skin at that depth. So, if you see, this is the cold receptor, it is close to the skin. This depth is say around say 0.15 millimeter. Okay. And if we see the warmth receptor, its depth is more than this cold receptor. Cold receptor is present at 0.15 to 0.17 millimeter, whereas the warmth receptor is actually present in the dermis, and which is around say 0.3 to 0.6 millimeter average depth of the warmth receptor. So, what does it mean? So, number of cold receptors are much higher than the number of warmth receptors, and cold receptors are present at shallow depth, and the depth of the warmth receptor is more than the cold receptor. So, this means that humans are more sensitive towards danger of from the cold than the hot heat. So, which is due to presence of higher number and shallower depth of cold receptor. So, we should be very careful about the cold receptor, because that we sense more, we are more sensitive towards cold. Okay. Now, so all these responses, this picture, this schematic diagram we have shown, the cold receptors and warm receptor. Now, we will not discuss the pain receptor. Now, normal cold and pain receptor, these are actually the activity at constant temperature. Suppose our temperature here, we are not talking about the variation in temperature. That means, if the room temperature is say or skin temperature is say 15 degrees Celsius, our cold receptor will act at this frequency, at certain frequency. If it is 25 degrees Celsius, it will act as maximum frequency, like that. Even so, at 45 degrees Celsius, cold receptor will not work, our warm receptor will work at its maximum frequency. So, this is the curve which shows the input frequency, that is impulse frequency at constant temperature. Okay. Now, what happened when the impulse, that temperature changes abruptly. Now, let us see. This curve shows the schematically the what happened to the warmth receptor. This curve is it's a B which shows the warmth receptors activity, and this C is the activity of cold receptor, and curve this graph A shows the temperature profile. Suppose, so this is the time against time, and here is the it is a frequency of impulse frequency. If now the temperature profile is that for certain time the temperature is constant. Okay. Now, suppose a person he is at constant temperature, suddenly he entered in a room of higher temperature. So, it shows the sudden change in temperature. Earlier we have discussed up to the constant temperature. So, here it temperature has changed to certain temperature. At a hot room he has entered, and now at that temperature he is there for certain time. Okay. And after that he comes out from that room and entered in a little bit cooler room. So, this is the and remains there for some time. So, this is the our temperature activity, temperature suddenly increasing temperature, remaining there for some time with higher temperature, and then he is coming out from that zone and in cold room he is staying. Now, what are the activities of our cold receptor, normal cold receptor? Will it active like normal constant temperature? It will active totally differently. Like in the warm receptors, it shows that with the increase with the time it gives a constant signal. Okay, that we have discussed. It gives a particular impulse frequency. So, like you can go back to that say for a particular say 25 degrees Celsius, it is giving a particular constant frequency. This frequency it will give, it will not change. Okay. This is for constant temperature. Now, here this is giving at a particular temperature, it is giving. Okay. Now, so this is the frequency. Now, if we suddenly increase the temperature of that he is entering to another room. So, suddenly the one receptor will start sending the impulse frequency at a very high rate. So, impulse frequency will increase suddenly, sudden jump will be there due to increase in temperature, and it will, as the person is there for some time at high temperature, but then gradually the impulse frequency will drop gradually. So, sudden change in temperature will have shocking effect. So, it will the sensor will suddenly increase the sensation, and then gradually the sensation will be dropped, and when the temperature is dropped, what will happen? The warmth receptor will stop its sensation. There will not be any sensation on suddenly dropping the temperature. Dropping the temperature, suddenly it is becoming cool. It is not gradual, sudden change in. So, its impulse frequency becomes 0, and at that temperature if the person remains for some time, after certain time, so it will again start sending some signal for constant whatever it was there, for certain constant temperature or something. So, it will give that amount of signal. So, this is giving that signal, it is because there is certain temperature. So, it is giving certain because this temperature is whatever this temperature, it is within this warmth zone, it is within the from 30 to 50 zone. This temperature is between say 30 to 50 zone. So, that is why it is giving this for warm receptor. Now, if we see the increase in temperature, so here in the this is the curve C shows the cold activity of cold receptors. So, at certain temperature it is getting this value may not be same for warm or cold receptor. So, that means this receptor, this temperature is within the cold reception zone, that means say 30 to 7 to say 42 degrees Celsius. For this, for cold receptor, this temperature is within this zone, okay. And as the temperature suddenly increases, what will happen? It will act just opposite. The cold receptor will suddenly stop its activity, suddenly it will drop, but after certain time, like warm receptor, it will again start sending signal, it will get. But when the temperature drops suddenly, its activity will increase suddenly, like warm receptor. So, warm receptors it activate this cold and warm receptor, it activates abruptly with the change in sudden change in temperature. So, its activity is maximum here, then again it gradually lowers, actually it drops, okay, its activity and become stabilized. So, this is the activity when we actually move from a warm place to cold place or cold place to warm place. So, this sudden shock is due to this activities, okay, of sensor. So, in case of abrupt increase in temperature, the warm receptors are strongly stimulated at first and sending impulse signal at high frequency, but it gradually fades rapidly during the first minute, followed by increase in temperature. So, as it gradually it fades out. So, after increasing and then gradually the activity fades down, then progressively more and more slowly until it reaches steady state, that we have discussed. Similarly, in case of cold receptors, the impulse frequency increases abruptly when sudden drop in temperature, and similarly it again this stimulation fades rapidly during first minute and following the drop of the temperature. So, after just dropping the temperature during first minute, it immediately shoots up, then gradually it is drop. These thermoreceptors respond to a steady temperature state at this lower rate, but at higher rate in the dynamic day. So, this at lower rate it sends. So, this picture, this graph shows at steady temperature, this is the activity, this is the sensation, but at changing temperature its activity is very high, its impulse frequency is very high. Now, one very common example, it is a lower rate, okay, but at higher rate and the dynamic condition of change. Dynamic condition means dynamic changing condition of the. So, very common example is that a strong sensation of cool or warm is felt upon entering a cold pool or hot tub. Suddenly we jump into a cold pool or we are entering into cold pool with a cold water. Initially we will be shocked because our sensation, impulse sensation is very high, but after remaining for certain time there, that type of sensation will not be there, it gradually drops. So, this is true for hot tub also. So, that is why our clothing has to take part to actually avoid the shock, cold shock, okay, or hot. Suppose from cold room or someone is entering from normal room to cold room, okay, he has to wear a clothing, so that to avoid this type of shock, okay. And opposite is true. Suppose someone is entering from normal temperature to the very extreme hot temperature. So, this type of shock we may encounter, okay. So, the temperature of the skin plays an important role for any thermal sensation, and a person feels comfortable within a narrow temperature of skin. So, our temperature zone is very narrow. Now, we can see this is the temperature zone, comfort temperature zone at different body parts, and at different body parts this range is little bit different. So, within this narrow zone, we suppose in hand we feel the zone, the comfort zone is between this and this, that is between, you can say it is a 35 to 30 degrees within that zone. Similarly, in front neck it is very close, okay, say around say 35. So, we can see the temperature zone is between 30 to 40. So, that 30 to 35 is the comfortable zone. So, at different parts of the body. So, lower temperature is at a solid line and higher temperature is shown by the dotted line. So, within that zone and different body part gets different comfortable range. Now, what about the humidity stimuli? We have seen the mechanical stimuli which sense the mechanical sensation like touch, pressure. We have seen the thermal stimuli, thermal sensors which actually sense the different types of sensation related to whether it is hot, whether it is cold, whether it is constant temperature, whether it is changing temperature. But we have to see the whether there is any humidity stimulation sensor. So, there are different types of receptors in the human body which sense different types of physical stimuli like including touch, pressure, thermal, cold, pain, but there is no receptor present which sense the presence of moisture or dampness sensation. So, but we may think that okay, we can sense the presence of our moisture or presence of sweat or presence of dampness, but these are not due to the presence of humidity stimuli or moisture stimuli. Moisture stimulation is not there. These are actually this we get with the help of either mechanical stimuli, mechanical receptor or with the help of thermal receptors, but there is no such moisture receptors present. Like suppose we have started sweating, we have started sweating, but we may not sense the sweat. We may sense warmth or cool, okay, but suppose our forehead, sometime we feel our at the forehead or some places it is a sweat, we may not feel, but when the sweat starts dripping due to its amount which it starts dripping, due to dripping it moves through our skin, okay, and that is sensed by our mechanical receptors indirectly. Then we can feel okay, that is it is sensing. Suppose we are pouring water, okay, during water pouring, what we sense? We do not sense the presence of water, we sense indirectly. That means it is due to its pressure, due to its flow characteristics or due to its temperature difference. If sweat is there at our body on the skin, when sweat starts evaporating, that means our body gets, our skin gets cooler sensation. So, thermoreceptor is indirectly sensing the presence of sweat. Now, so what we have seen that we have mechanical receptors to sense mechanical activities, mechanical stimuli. We have thermal receptors which sense the thermal different thermal stimulation, and there is no humidity receptors, and humidity reception we get indirectly with the help of mechanical receptor and thermal receptor. Now, in this segment we will discuss that how to measure this sensory perception. So, we have various techniques to measure the sensory perception. We have seen that the receptors are there, different receptors are there which receive signal. Now, to how to measure? So, first measurement technique is it is called 2-point threshold technique. So, 2-point threshold technique means there is two indentation is there. So, the sensory perception of human skin is commonly measured by 2-point threshold method. What is 2-point method? This is the minimum distance between 2 point like indentation applied to the skin below which only one single point of contact is detected with the sense. That means that different parts of the body has got its sensation. So, it is contacted with the 2 pointed object at different distance. So, that the sense of detection, that distance can change. So, the minimum distance between 2 point like that means, if we keep on changing, suppose at a certain distance it is kept. Now, if we keep on reducing the distance of this objects, the points, at certain point we will start, our body will start sensing as if it is a single point. That point is called minimum distance between 2 points. So, that is the one measure of the sensory perception of the body. Okay. It will, our skin will sense as a single point. The pressure applied below the 2 point threshold, that is 2 point threshold point, okay, the distance feel like a 1 point. Okay. So, this 2 point, this is called the 2 point threshold distance. So, if we apply pressure below that distance, then our skin sends signal as if it is a single point. So, this is actually method is known as 2 point threshold method. So, and beyond that a person can feel that there is a 2 distinct points are there. Okay. For the values it's vary from different parts. So, at finger it is very close, it is around between around 2.5 millimeter, and it goes as high as 50 millimeter at say 5 centimeter at different other zone. So, if we see, this is the technique. So, these 2 indentations are there, 2 points, it is it's touching the 2 points, and if the person says okay, I cannot distinguish whether it is a 2 points or single point, that is that you can increase little bit distance and gradually, and that the point where he starts sensing there are 2 separate sensation, which is known as the 2 point threshold distance. Okay. And it depends on the sensitivity. If body sensitivity is poor, it is not sensing, its mechanoreceptors are not working or receptors are not working, that type of test one can do here. Okay. And this picture shows that different zone, different parts of the body, what is the 2 point threshold distance. So, at finger, okay, finger it is a minimum, so around say 2.5, this is shown, it is a 2.5 zone, okay, and then it gradually increases. It is a very common sensation which we normally sense the texture of fabric by finger, not by thigh or something. That means there its sensation is not that. See, you just see thigh, it is very high, calf it is around say 45-50 millimeter, which means, so within 40 below that we cannot sense that there is a particular texture or not, there is a 2 points or not, it gives rough signal, and that is why, and but by the finger we can sense whether there is a within maybe within say 2.5 millimeter at that distance, we can sense that there are 2 different objects are there. So, that actually indirectly we can correlate with our comfort or body sensation, we can correlate with this. This is the lowest zone, and here at the calf it is a highest, okay, and this is the mean 2 point threshold distance. This is the the same data, it is shown in different picture. So, we can get idea about that. At the calf it is maximum. Okay. So, we can see the data here, it is a 2.5 millimeter, a thumb it is there, and you can see this is the minimum zone, that is the most sensitive zone. So, we can texture or anything we can test with this help, and the calf and this joint it is very high. Okay. Now, we will this 2-point sensor scale discrimination by this we will next class we will continue with this measurement technique, okay, by 2-point threshold and different other techniques we will discuss. Thank you for that.